Have you ever thought about how a robot actually knows where to move and how to get there? In this project, we explore how robotic systems use programming, math, and coordinate transformations to complete precise tasks. Throughout labs 1 through 3, we built up the foundation needed to control a robotic arm, starting with basic movements and ending with solving a complete task. In this video, I'll walk through what we learned and the method we used to solve the problem, and show a full demonstration of the robot in action. But first, here are the group members.
Hi, my name is Liam Matheson. I'm a mechanical engineer. After graduation, I plan to work for General Motors back in Detroit. As a part of this team, I've worked on doing code and hands-on troubleshooting.
Hi, my name is Ryan Murtha. I am currently a senior in mechanical engineering. After graduation, I plan on working for a naval contractor called PPMI just outside of Pittsburgh. And for this semester, my main role in this group has been mainly documentation management and turning in all of our assignments, mainly managing this video and doing a lot of code help whenever we need it.
My name is Grant Panetta. I'm a mechanical engineer. After graduating, I have a job lined up in Oak Ridge, Tennessee. For this project, I was mostly dealing with the hardware, dealing with resetting and calibrating the robot, and dealing with any issues or problems that the code had.
Hi, I'm Ben Skrinkowski. I'm a mechanical engineering major. Plans after college are to begin working in construction management, and my main role in the project was being a coder.
In Lab 1, we learned the fundamentals of the Dobot robot, including basic movement, coordinate control, and how to use end effectors like the gripper and suction cup to pick and place objects. In Lab 2, we expanded into vision systems by capturing image, performing feature matching, and calibrating the robot to convert image coordinates into real-world positions. Finally, in Lab 3, we combined these concepts by implementing a robot-to-robot communication and vision-guided automation. Overall, these labs built the foundation for controlling and automating a robotic system. To solve this project, we combined robotic kinematics, vision processing, and program logic to create a fully automated system. First, we used the vision system to detect objects in the workspace. By creating templates and using feature matching, the robot was able to identify the location and orientation of each object. Next, we applied calibration to convert the image coordinates from the camera into real-world coordinates that the robot could use for movement. This step was critical to ensure accuracy when picking up objects. We then calculated the required joint angles and positions for the robot arm, using program move joints and transformations that allow the end effector to properly align with each object. Finally, we implemented logic and sequencing and flowchart control of the robot actions, including picking, moving, and placing objects in the current location. By combining these steps, we created a system that consistently and accurately complete the task. While this approach allowed us to successfully complete the task, we encountered several challenges along the way that required adjustments and problem solving.
One of the big challenges we faced in this project was the Dobot not cooperating with us. So how we solved that was just a lot of trial and error through trying different things, resetting the Dobot, and yeah.
Another challenge that we faced was matching the correct letters to the correct slot. Most of the first iterations of the code that we went through was matching a D to a G and then a G to a G, which we fixed by correcting and making the fast matches more distinct within the code.
Another issue that we faced was because we weren't given the same computers every single lab, we had to save our files to a hard drive, and that put a lot of dependence on multiple people that weren't in our group. So there was a lot of challenge in getting that hard drive to us.
After working through these challenges and refining our approach, the robot is now available to successfully complete the task. Here's the final result in action.
Kiss. Romeo and Juliet. Just fine, mute the video, bro.
I ain't muting the video.
Move the B.
Nice, okay.
It does, it's just